Hello everyone. This is a demo of how to produce audit and compliance within the nuclear waste processing industry using TRE. One of the main requirements in business systems today is to provide full access audit and compliance. In finance, health, asset management and any other closely regulated industry, there is a high and growing need to provide compliance, especially when the system of record is continually updated and or corrected, thus creating a history of different states within the system for any particular record. This creates the requirement that the system of record can be comprehensively shown to the auditing authority so that they can be shown what was known and when it was known. TRE provides this level of audit and compliance as a standard out-of-the-box feature, and in doing so simplifies application development and massively improves application development productivity. Here is one example of how TRE addresses a real business audit challenge, this time within the nuclear industry. As nuclear material is processed, it is contained, weighed, assayed and moved through various plant locations, and so a life cycle history of data builds up as the process continues. Occasionally mistakes occur, and once a mistake is detected, the life cycle needs to be retrospectively corrected within the system to reflect what actually happened. The auditing facility, a standard requirement of the auditing facility is for nuclear waste systems that are processing nuclear waste to first of all record what has happened, quality assure that that check is okay, send the intent of that action to the database after checking it's been consistent, to allow the database to provide answers to the questions: what do I have now? What did I have at time T? And what did I think I had at time T? Item history reports provide answers to these questions. The database provides answers to also what went across boundaries within the plant, what are its properties, and all the data must be version controlled. That database feeds the accounts systems within the plant itself, and that information is sent on to ICRs. There are many real-world scenarios that can occur within the nuclear waste management. For example, assays may be corrected after material has been sent to a customer. The wrong drum may be sent to a customer. The items may be placed in the wrong location within the plant. These three scenarios could be continually being made and go wrong, and we have to keep recorrecting things. So the idea that more than one correction occurs, and even something quite such as a containerization went wrong within the plant. When these situations occur in the real world, the system recording the location and data for the nuclear material has to record the intent and the correction, so that Euratom or the registering the regulating authority can be shown what went wrong, and that the data was corrected within the system and no nuclear waste was lost during the process. So this is a basic fundamental requirement. The regulating authority Euratom demands that the system of record can provide a full and complete audit of these histories and corrections at any time, pre or post updates and corrections. In order to demonstrate this facility, we have created a very straightforward schema within an Oracle database. The picture you see now depicts the current view schema. We have material containers which hold nuclear material. The definition is that nuclear material touches the inside of the container. We have containers. Material containers can be contained within a location or within a container, which itself can be contained within another container, and those can also be located at a location within the plant. The plant itself is a series of locations, a hierarchy of locations. Each container has a container type. Each material container has a material container type, and the contents of those material containers are assayed. Of the 5 scenarios that we mentioned earlier, we are now going to go through scenario 1, where an assay is corrected after a drum is sent to a customer. This scenario takes several steps. A drum of uranium oxide is produced. The drum is assigned a less accurate production weight. The drum is assigned a more accurate accountancy weight. The drum is assigned an assay, then is placed in the store, then is containerized. The drum is sent along to a holding area, but we forget to tell the system. That's where the error occurs. The drum is sent to the customer, and at this point we realise that we forgot the movement to the holding area. We realise that the drum has been associated with the wrong assay, and a link is withdrawn and a new one is assigned. Depicting this scenario visually, we can see that we depict a store, a shipping compound and a customer as locations. We take a drum 001, we tare weigh it, we fill it, we sample it, production weigh it, and then move it to the store. We do a more accurate accountancy weigh, apply the assay, and then move the drum to the shipping compound. But we see that we have forgotten to record the fact that drum 1 went to the shipping compound, so that when we come to the point where we have to send it to the shipping compound, it is not there yet when we try and send it to the customer. We then correct the mistake by putting drum 1 into the shipping compound, so that we can therefore send it to the customer. We then realise that the assay that we applied in the store was incorrect. We apply a new assay. That is the end of scenario 1. We're now going to demonstrate the database and how a database copes with that scenario. We'll begin with a completely empty schema. So I have a script that generates the schema that you saw depicted in the slides earlier. So we are creating a new temporal schema using TRE. It's taking that current view design and creating a temporal version of that design, so that histories and corrections can be stored within the system, thus providing full audit and compliance inherently from within the system, rather than being coded by the developer. To show that this is a real demo, this script just shows us the state of the data before we begin the demo. We can see that we have a table for locations, code, name, type and location, and if we just try and select information from the locations table, there's no data at the moment. We've just got an empty schema. Similarly for container types, containers, material container types, material containers and assays. So we have a generated schema ready to receive data, reference data and transactional data, updates, inserts, corrections, deletes, etc. I'm now going to run the script. This script is just going to populate the reference data and the transactional data, just holding, occasionally sleeping between transactions, just to provide some transactional difference in time between one operation and the next. If you take time to look at this, if you take time to look at the repeat of this demonstration, you can see the actual commands being used are very straightforward update insert commands. We're now going to run the reference data script again, just to show that something has happened within the database. So now when we show the locations, we can see we've got several locations in the locations table. We have several container types, a container ISO 001, several material container types, and an assay that occurred during that process. Finally, there's a script that shows the reporting of that data at various transaction and valid times. We set the system up to display times from within the database in a certain format, and we begin by showing at transaction time before the 3rd of the 1st 00, there were no containers, no material containers. The material container D001 had no content history, and the material container D001 had no movements. If we just fast forward in time to after 3rd of the 1st transaction time, we now see that the same report shows that there were no containers, but there was a material container D001, a large drum that was filled with a tare weight and an assay. The material container D001 content history was that it was tare weighted, filled, and then the mass was calculated based on the assay. So far, the material container D001 has had no movements. It has not been moved around the plant across an MBA. After the 5th of the 1st 00, the situation has changed, and TRE can provide the true view of the data at that point in time. You can see now that the container, there are no containers, but D01 is now in the store, has an observed weight, and you can see that the material container content history has now moved from location M1 into the store. You can also see that that movement has been recorded from N1 to the store. So at any point in transaction and valid time, we can ask the database to call back the current state, the state of the data at that point in time. After the 6th of January, we can see that this is the current situation. After the 7th of January, we can see that now we have the drum has been moved from the store to the container. It has been containerized into ISO 001, and we now have an ISO freight ISO 001 drum store within the drum store, and D001 is in that store, in that ISO store. After the 9th of the 1st, we can see that the containerization has occurred. After the 10th of the 1st, we can see that now the container itself moved to the skip from the store. And after the 11th of the 1st, we can see that the ISO container, ISO 001, has been shipped to the M3. After the 12th of the 1st transaction time, we can see that the system is now in this state. So, even though the current state of the system with all the transactions that have occurred are as they are now, we can move back in transaction time and across invalid time for any time in transaction and valid time, and write simple queries to produce the full audit and compliance required by Euratom. This has been achieved using a very straightforward schema. From a developer's point of view, all they have to do is design a current view schema to model the business requirement, and then provide very straightforward insert, update and delete commands to the TRE layer underlying this schema, and TRE will take care of all the audit and compliance and the storing of the history and the correction of the histories for you. Hopefully that demonstrates the power of TRE. There are several other scenarios that we have to show. For the purposes of brevity, we've only shown scenario 1, but all 5 scenarios are available if you wish to contact us. Thank you for your attention, and I hope to hear from you soon.